Hey everybody, and welcome back to another fun and exciting pre-calculus class. In today's lesson, we'll be jumping into 16.4, only 3 lessons left, so hang in there. We're going to be talking about acceleration and the second derivative. Page is number 317. Page 317, let's jump down there and let's look at it. So basically, acceleration is a form, it's a way to use the second derivative. In the last lesson, we did talk about acceleration and what's called average acceleration. Basically, the idea of taking and seeing how fast something is going over a certain amount of time. And we use the first derivative to do that. So in this lesson, what we're going to be doing is now taking the acceleration to the next level, and that is finding, you can look down here, it's instantaneous acceleration. What does that mean? How fast is it going at a certain moment in time? And you determine what moment in time you're looking for. So, for example, 3 seconds into your trip or when you leave somewhere, how fast were you going at that very moment? Okay. It depends on what you're looking for. And they use this in rockets and space exploration in all kinds of different applications. Calculus is actually used in an amazing amount of things that you don't even know that it's being used in. So let's go ahead and look at this. It's actually not that difficult of a lesson if you got the last lesson, if you were kind of tracking with the whole idea of the derivative. Okay, and now we're just going to do it again. So let's go ahead and look over here at the computer screen real quick. And what do I mean by do it again? Well, here we have our main function, the function of x. In the last lesson, we learned how to take that function of x to the function prime of x, right? And that's what we use to find our average acceleration. Well, in this lesson, we're going to go one more step. We're going to take a second derivative, and now we're going to have the function double prime of x. Believe it or not, this can keep going. You can have the function triple prime of x, okay? The fourth, the fifth, the sixth, the seventh. You can keep going with that as long as you have enough variables, all right? As long as your polynomial is big enough, then you can keep going with that. One thing that I will show you, so we're going from left to right. You can also go back this way, and we're going to be learning about that in a couple lessons, okay? So, but for right now, we're going from left to right on this chart. One thing that's kind of cool is you can actually come over here and there's one more, and that's the big function of x. So there's something actually, so you have the function, you can actually go this way and get one more thing, and you'll get to that when you get to calculus class. But for what we're doing right here, we only need the first and the second derivatives. So main function, first derivative, second derivative. That's what we need for this lesson. You can go ahead and skip over to the next page in your book. Page 318 is where you'll find this example. Now, I have it written out, and I am not a big fan of this example, to be honest. If I was writing the book, this would not be the example that I use because it's fairly complicated. But we can do this in a way, I think we can simplify it, and I think that's really going to help you to see what's going on. First thing I want to do is kind of break this up into 3 separate pieces, right? Because this is a polynomial. I know it doesn't look really like a polynomial that we've been using, but it is a polynomial. So let's go ahead and break it up. So the first part that I see is this 12m right here. So we're just going to write 12m. The second part that I see is this piece right here. So we have a plus, and then we have 10m divided by s times t. This is a t, not a plus sign, okay? I hate t's in algebra, and right, it's really hard to tell the difference between a t and a plus sign. So what can we do to simplify this out? This right here is like a measurement. We could take this out and then add it back in at the end because it's just saying that it's meters per second, okay? So let's just kind of leave that alone, and now we're going to get 10 times t, or 10t. And then we have plus, and then we have one more piece down here. The last piece of this thing, and again, if we get rid of this right here, this is just a measurement. and we can add it back in at the end. It's going to look like 1/2 times 9.8 t squared. Now, let's do one more thing to make this look more like a polynomial that we've been using in the past, and I think that this will make a lot of sense to you. This is not written in standard form, right? Typically, we write the t squared at the beginning. So, and you could also go ahead and multiply this out right now if you want to, and we could say we could take half of that, and that would give us 4.9. So what I want to do is I'm going to take this piece and move it up to the front. We're going to put it in order. So this is going to be, again, I multiplied this right here and got 4.9 t squared. So we'll put our t squared, and then we're going to use this term next. So then plus 10t plus 12m. And we're just going to get rid of that m too, because we got rid of the rest of the measurements there. So m is meters. All right, now we have it in kind of a format that makes a little bit more sense to me. All right, now if you want to do it like the book does it, if you want to, they leave it with all that kind of mess. I'm just telling you this is going to be easier. And I mean, here's something else that we could do. Honestly, if we wanted to get rid of those t's, we could just write x's right here because it's the same thing. And then we can just transfer it all back into the other format here when we get done. All right, so what we want to do now is, so this is still our main function. This is our function of x. Actually, it was a function of t. I turned it into a function of x. So now we want to get our first derivative. So we're going to get the function prime of x. All right, so this is going to equal, and then we're going to go ahead and solve this. How do we do this? All right, so remember, we take this 2 and we multiply it here. Well, it just goes back to our 9.8. So 9.8, and then our x stays there, and then we subtract that by 1. So x to the 1, we don't need to write that. So that's how to take the derivative. If you forgot that, then go back to the previous video and watch that again. Then we have our plus, and then we have this one right here. So this is x to the first. So we multiply that times 1, and we get 10. And then we say 1 minus 1 equals 0. Anything to the 0th power is 1. So 10 times 1 is just 10. Plus 12. But anytime you have a constant, you just eliminate the constant. So our first derivative is going to be 9.8x plus 10. Now, the question does say find the instantaneous and the average velocity. This right here is going to be the average velocity. Okay? We're going to come back to that in just a second, but let's continue and let's do the f double prime since we're finding the derivatives. And let's take this down to its second derivative. We're going to do the same process with this here. Remember, this is a 1, so we're going to take this and we're going to multiply it by that, so it's still just a 9.8. The x goes away because it's 1 minus 1, right? And then that just makes it go away. This 10, we get rid of it. So the second derivative of this is just 9.8. So this is going to be the formula for how we find our instantaneous velocity. Okay, so we're going to use both of those. We're going to use this one for average, and then we're going to come back and we're going to use this one for instantaneous. All right, so if you go back to your book on page 318, you're going to see that our t, and we already subbed this out, right? So I could go back and sub back in the t now. So anywhere that there's an x, I'm just going to get rid of that, and I'm just going to put the t back in here for our time. So we have this to the t, and this to the t, and then this is just the function of t. All right, so everything's plugged back in. Now, here's all we need to do. Our problem gave us this. It said it wants you to find it for the time of 7.5. So we're going to plug into both of our equations right here. We're going to plug in. Well, let's actually do the instantaneous first, because this is a super easy solution right here. We just plug in right here, and we get that the function of 7.5 equals, so in other words, our instantaneous is just 9.8 9.8 what? Meters per second squared. So we're just subbing back in. Remember when we got rid of that meters per second squared up here? We're just subbing that back in. So there is your answer for instantaneous velocity. Now, we have a problem though. We did not solve this one right here. We did not solve our average velocity. So we're just going to take this and we're going to plug in. So we're going to take this 7.5 and we're going to plug it in right here. I would just suggest using a calculator on that. So we'll just grab the calculator and we'll do 9.8 times our 7.5 plus our 10. And that's going to give us 83.5. So our answer here, 83.5 meters per second. This is not meters squared per second. This is just meters per second because, again, this is the basically this is taking the first derivative, and we would use meters per second in the average, but then in the instantaneous we have to use meters squared per second. So this one here is going to be our average velocity. And there you go. There's the kind of the whole deal. Now, is it complicated? A little bit, but it's not bad. And I feel like once we kind of stripped away those meters per second and we put it into the right format, hopefully that made sense for you as we went through that. Now, I'm going to go ahead and go through one more. So let's just kind of pick one of these. Let's pick... Number 10 looks like fun, okay, right? So you're like, no, none of these look like fun. Let's do number 10. So number 10 on page 318 is the function of x equals 2x cubed minus 7x squared plus 4x minus 9. Now, all it wants you to do is find the second derivative. We don't actually have to plug back in for this or anything like that. So we're just finding the second derivative. So here's the first derivative, and we would do that by following our steps. Here's the steps. We take our exponent and we multiply it by the coefficient. So 3 times 2 is going to give us 6x, and then we subtract 1 squared, minus, and then we're going to take our 2 multiplied by our 7. That's going to give us 14. And then we're going to subtract 1, and we're just going to get x to the first, or just x. Now we're going to take our 1, and we're going to multiply it by our 4. So just get a 4 plus 4. The x goes away on this one when we subtract our 1. So x goes away, and then the derivative of any constant just goes away. So there you go. There's the first derivative of that one. And now we want to find the second derivative. So f double prime of x is going to equal, again, same process. 2 times 6 is going to give us 12. 2 minus 1 is just going to give us our x. 1 times 14 is 14. The x goes away. The constant goes away. And so here is your second derivative of 2x cubed minus 7x squared plus 4x minus 9. Okay, here's the second derivative of that. There's first derivative, second derivative, 12x minus 14. And you might be thinking at this point, like, what in the world? Like, what is going on here? Why am I finding this stuff? Let me promise you, when you get to calculus class, you're going to be like, oh my goodness, this is exactly what I was finding it for. This makes sense. These derivatives are almost like this magical little formula that you use to solve different problems in calculus. So you have to know this formula, this way to solve this very well, because you're going to continue to use it all the way through calculus. It's never going to go away. You're going to use it at the beginning of calculus all the way to the end of calculus. So keep working hard here. Keep practicing on these. Keep doing that homework. And if you missed anything in that video, go ahead and scroll it back, watch it again. It's really all I have for you in the video, right? I know you want more. You want it to be harder. I'm sorry. That's all I can do. So this is just kind of a copy of the last lessons, the last 2 lessons. You're just doing it again. You're taking it to the next step. You're just practicing it just a little bit more. All right? That's all I've got for you. We'll see you later. You have a good one. Bye-bye.